okay? So don't ask me what day it is, what time it is, and how many events are already moderated, but this is really an important one. Maybe, Mike, we can go a little bit higher. Our neighbors are very noisy now. But so this is an event around LC3, scalable and sustainable low CO2 cement solution. So we will have, I will make a very short introduction. Then we have a presentation by Karen Scrivener. And then we will have experience sharing from 4 companies: Argos, Holcim, Heidelberg Materials, and GSW. Argos is going to be with us virtually by video. And we have kept showing always a reference to a roadmap. We have had many sessions around CCUS here. We have already had many sessions around efficiency in buildings and procurement and efficiencies in construction. We had a session on concrete as a carbon sink, on the recarbonation. And today we are actually now in the orange zone this afternoon on clinker substitution according to a roadmap. This is 9% of the reductions. And calcined clay are very important, but I don't want to steal your speech, Karen. But the GCCA roadmap, it's because we all know that slag and fly ashes are going to become less available in the future, and we have to look at other clinker substitute as we move forward. And that's it for my introduction, and I will pass on to you, Karen.
Okay, Claude, thanks very much for the introduction. So it's quite difficult to present LC3 in 10 minutes, but I'll do my best, so we may skim over some points. But I think it's no secret to everybody here just how much cement and concrete is hitting the headlines now. The rate of heavy emitting industries on Monday, and come from the cement breakthrough launch by Canadian government. And, you know, here I think LC3 is really a key technology for the following reasons. First and foremost, it's basically just a blended cement. So it's a blended cement like we've been using already for many decades, and this means we can be confident in its long-term performance. It's already covered in many existing standards around the world, ASTM, EN standard, Indian standard, Chinese standard, nearly everything in cement. There are some issues maybe when you come to concrete, but then we're in the process of working on the downsides. And the first problem that everybody seems to stumble on is where you find the clays, but here we can help you out. You need to have calcination, but this can be as straightforward as using an existing cement kiln, and you have a different workability. So Claude already showed the GCCA roadmap. This is kind of a generic version. The vertical scale is not quantitative. It's just showing the different levers we have. But the basic message here is that there's a huge difference in cost. So the ones at the top can be implemented at low or even negative cost, and when you get to carbon capture and storage, this is when your costs go up an order of magnitude or more. And so clearly, I think it's more interesting to maximize what you do at the top before you come to what you have to do at the bottom. It's just financial. And, you know, many people are proposing miracle solutions. I haven't got time to go through these all, but they're, you know, I can tell you they're not going to deliver. If we look at one very popular one, which says, well, let's get calcium not from limestone, we can use basalt. Well, yes, you can. Slight drawback, it costs 20 times as much as producing clinker the way we do today, and you end up with 80% of reject material, and then you could use that same basalt or olivine or whatever you have, and you could spread it on fields, which is kind of a lot cheaper. So we start with Portland cement, and then of course we know that we can reduce the clinker factor. The vast majority of cements in the world today already contain these substitute materials like limestone, like fly ash, like slag, the big problem is that the two most used ones, apart from limestone, slag and fly ash, are already available in quite limited amounts, and these amounts are likely to decrease in the future, particularly fly ash, because we need to phase out coal. So, you know, it's not a question that we shouldn't use slag and fly ash, but, you know, these are going to disappear, and even today they're not much. Now, if we look at the level of clinker substitution worldwide, according to the Getting the Numbers Right roadmap, it's been hovering around 20% for the past decade or so. So we need to go much further than this. And if we remove the limitation on substitute materials, for technical purposes, we could easily imagine to go to a substitution of 40%, which would represent a saving of 400 million tons of CO2 worldwide, which is like 1% of the entire emissions today. And I think on a horizon of 2050, we could even imagine to double that to like 50-55% substitution, which would have double the CO2 savings. So it's fairly straightforward why LC3 reduces CO2. We substitute the CO2 emitting clinker with a combination of calcined clay and limestone. Now, calcined clay has virtually limestone has virtually zero emissions. Calcined clay, you do have to calcine it, but the heat you need there is much, much less. So you still gain a lot. In a nutshell, you have 50% clinker substitution. You will save 40% CO2. And as we see here, you will get similar strength to Portland cement in as little as 7 days. Now, there are issues and questions on workability. This is, one thing that is quite different from existing materials, but it can be, you can use existing admixtures that are on the market today to make good workable concrete, even in these conditions like here of quite simple low-tech concrete with volume batching. You can see the concrete flow is very good. You have excellent cohesion, really no bleeding or anything like that. And all of this can be achieved at usually cost savings. I mean, this is a study we did back a while ago where all the figures are in this report that can be downloaded on the website, but you can usually save compared to the OPEX production of OPC in both an integrated plant, but especially in grinding plants. Of course, the critical question is what kind of clay, and basically we need to have some of this mineral kaolinite, which is this so-called one-to-one clay, and because of this crystal structure, both the calcium and the aluminate component are available to react. And the aluminate component actually reacts with the limestone, why you have a synergetic effect for this coupled substitution. And the kind of kaolinitic clays you need are really very widely available just about everywhere. You see this orange color, and even some regions you don't. You can, as I say, calcine the clay with existing technologies, either a rotary kiln, either a flash calciner. You can, most importantly, even do this in an existing clinker kiln. There was an announcement just a couple of days ago from Angola where they're converting 4 kilns to producing calcined clay. So we'll hear more from some of the pioneers. This is the plant of Argos in Colombia. This is the plant of Simpor in Ivory Coast. And what's important is that today, the LC3 has been used in, just about every application. This is some pictures from Argos. So I just want to finish by giving a very quick insight to the range of applications in this short study we did compared to concretes prescribed here in Dubai. So we took 3 strength grades, a kind of average strength, an intermediate strength, and a high strength. And these compositions here are the prescriptions that are in the code, which currently specify the use of slag and the use of fly ash. Well, of course, you don't produce slag in the UAE here, so you've got to import it from somewhere like Japan, which is very expensive. So in the first step, we simply substituted all the binder content with LC3. But then we made a second step because we found that these concretes were respectively either over-designed or under-designed, so we wanted to more meet the strength specification, and there we could further reduce the CO2 footprint. So these are the results. You see on the left there the conventional concrete in the code now. You can see for the two lowest strength classes that these really exceed the design strength, which is not necessarily a good idea because then your reinforcement dimensioning is wrong. And for the highest strength grades, they weren't meeting the specification. So after redesign, we got the results in green there, and when we look at the CO2 savings, we could see for the two lowest grades, we have a saving of between 20 and 25%, and even for the higher strength grades, where we had to achieve a higher strength, we could still save 10% of CO2. And these are the results for the chloride ingress by the rapid chloride permeability test. And you can see all the LC3 results are in the very low category, whereas some of the concretes in the current code were actually only in the low category. So these are some of the announcements from around the world. I'm not going to dwell on this because you're going to hear from some of the manufacturers themselves, but we are working with over 55 different countries on different levels of interaction. So the key message is, we can reduce a lot of CO2 without going to carbon capture and storage by working on SEM reduction, by working on good design of concrete and on the structural level. And all of these can lower costs. You have to put some carbon capture and storage in, but then you have a really big increase in cost. And if you're looking to reduce the clinker factor, calcined clays are really the only option for extending the use of SEMs. That's to say, going beyond what we can currently do today with slag and fly ash. So I'd like to thank you for that and hope we weren't over time.
No. Thank you, Karen. Thank you so much. So as we said now, we are going to go through experience sharing. The first one is a plant that we already saw, is the Argos plant. So Argos, we are going to hear from Thomas Restrepo, which the Chief Future Officer at Argos. Thomas is not here. He is going to be on the video. So
hello, this is Thomas Restrepo, Chief Future Officer at Cementos Argos from Colombia. And today I will share with you our experiences on the production and commercialization of limestone calcined clay cement, the green future today. These are the reasons why Cementos Argos chose to build a 450,000 tons per year calcined clay line at its Rio Claro plant. First, the Rio Claro plant is strategically located in the center of the country, serving the main urban zones of Bogota and Medellin. Second, that plant has no access to any type of known supplementary cementitious materials such as slag or fly ash. Third, the regulatory context for performance-based standards in Colombia, which is inspired on ASTM standards, allows for blended cements to be used in all the way from residential applications to infrastructure projects. Fourth is that when we compare CAPEX and OPEX figure side by side with clinker process and a new calcined clay process, we found that in both terms, calcined clays were more competitive. And finally, when we decided to increase production capacity, we were also looking at ways to dramatically reduce our CO2 footprint, and calcined clays were the path forward. These are some of the key figures of our limestone calcined clay plant in Rio Claro. We have produced since 2021 a total of 370,000 tons of calcined clay. The cost of the clay has been reduced by 20% through the ramp-up process, and it is much cheaper than the clinker produced at the same plant. the CO2 savings compared to the US industry average Portland cement range between 10% for the higher clinker, more high performance product, and 32% for the lower clinker products such as bagged cement or general use cement. Finally, when we installed the calcined clay process at Rio Claro, we decided to fully transform the whole portfolio of products out of that plant. So it means that every cement that has been shipped since 2021 at that plant has been used with calcined clay. So all of our products in the Rio Claro are limestone calcined clay cements. Now I will show you some applications of our limestone calcined clay cement in Colombia. This first application is a housing solution, very high-end application, where concrete was exposed, so color, finishing, and in general, all the properties of architectural concrete were needed. In this picture, we're showing some decorative concrete applications where you can see both at the roof and at the wall on the left side, the finishing that we had with that concrete. This is a commercial project in Medellin. It's called the Arcadia Shopping Mall, and it was completely built with this limestone calcined clay cement from Rio Claro. The limestone calcined clay cement of the Rio Claro plant in Colombia has been used widely for the 4th generation concession roads program in Colombia. Here you see an application of a tunnel. So this product was used all the way through the tunnel in the works that you see at the entrance and the exit of the tunnel, and also in the shotcretes and the paving and all the different construction elements that this tunnel had. Here you see our limestone calcined clay cement being used at a viaduct over the Cauca River in Colombia. You can see it's a very impressive bridge, very high, quite long as well, with very demanding structural performances. So this product is used in every kind of application that's going out of the Rio Claro plant. We have also used this cement in the mass transportation solutions in Medellin. So this is a cable station in the middle of the city, as you can see, where we used this limestone calcined clay cement to build all the pillars and in general all the stations and everything that was needed for this project. Finally, this is how the Rio Claro plant looks like after we installed the limestone calcined clay process. At the bottom, you see the calcined clay process with the dryer, the rotary kiln, and the rotary cooler. Then this supplementary cementitious product is then transported to the top left of the picture, where we have the blending station, where we produce all types of cement in our portfolio of products. Thank you for following us.
Yeah, I think we can. I really admire the video because sometimes it doesn't work and it's really nice. So with this, I've gone too fast on the slides. We will go from Argos to Holcim.
So I'll do my best here. Why do I say that? I am not, unlike Karen, I am not a calcined clay expert. And I promise you there are real calcined clay experts at Holcim, but it's not me. So I'm relaying this message on behalf of my colleagues. think the main message is this one, which is similar to what Karen was relayed. It's a globally scalable solution that can quite drastically reduce the carbon footprint of the products that we put on the market today. It's available today, and it can be sourced, processed, and sourced locally, which is an essential component, let's say, of our industry. From the global north to the global south, there Karen's map of availability of clay around the world will clearly illustrate that. I'm not going to read it, and I will repeat it, I think, another 50. You can see that, of course, again, as Karen said, the idea here is to seriously reduce your dependency on slag, but also work it for a very broad range of applications. And you have seen this is a projection of a marina in Marseille, which will host the sailing events of the 24 Olympics, and this calcined clay cement will be used in that project. So it's really high-end projects. The real breakthrough came in 2023 when we launched a full-scale calcined clay production facility in Saint-Pierre-la-Cour in France. This eco-planet, calcined clay eco-planet, has a 50% reduced carbon footprint. We use there a proprietary technology that we call Proxim A Tech. Can't tell you much about it, but my colleagues can. The idea there is to produce up to 500,000 tons of low-carbon cement per year in Saint-Pierre-la-Cour in France. Also use on a very broad range of application, and here let's say the innovation is that you use bio-based AFR with waste heat recovery, which basically brings you to a clay calcination which is close to zero CO2. So you really have a double benefit there. It's not just in France. We've started working with that in Mexico. Again, super high performance in terms of CO2 reduction. It's used in a different range of application. As you can see on the photo, it's small precast, it's bricklaying and non-structural concrete. And this is a major, for operations in Mexico, it's a major lever to reduce their clinker factor with calcined clay and limestone. The point of this, you can see it's really commercialized. There's a full product range, and you have all the marketing activities that go with it. So it's not just a little project on the side that we don't talk about. This is really fully commercial with the advertising and what comes with it. So it really is a firm presence on the Mexican market. Spain. Again, you can see here a slightly less aggressive carbon performance, but 30% nonetheless. This is again a different range of application. This is for reinforced concrete, for large volume projects, and even used for dams, for compacted concrete dams. So I think the point we see there, you've seen the range of countries in which it's made available and the range of applications. So I think you mentioned that, Karen, is that it's adaptable to the whole range of applications that we go through, and this is an illustration because it's vastly different from what our colleagues do in Mexico. Italy as well. This is probably the best performing and lowest CO2 reduction we have achieved to date with calcined clay, minus 55%. Again, it's huge on large scale application. You can see there photos of massive structural works and buildings. mass concrete again, but also application here in aggressive environment, marine environments. So again, showing the variability of the use and the flexibility that calcined clay offers you. And then last but not least, we've started doing that in the US. We're less advanced there, but it starts to be used there. To tell you the truth, I'm not able to tell you the volume of what we use there, but it started to penetrate the US market. You have there a picture of a building in Salt Lake City. As you can see there, again, it's used for large-scale project precast structural applications. Again, available on the market today, and with all the marketing that goes with it. So it's really noticeable presence in the market. Claude, or Karen, I don't know who moderates.
No, I'm the moderator.
You're the moderator, so I will stop here.
Thank you, Cedric. And yeah, I think we should applaud everyone because you're right, Karen. You're right. We need a bit more energy here. So more project. Winston from Heidelberg Materials.
Thank you. Yes. So welcome everyone. Winston Beck from Heidelberg Materials, and similar to Cedric, also not an expert on the issue, but I will mainly introduce two of our projects, and a lot has already been mentioned about the advantages of calcined clay and also some of the challenges, of course. So I will quickly introduce our sustainability strategy and how the role of SCMs. So I think, as I have mentioned in some of the previous presentations, we will reduce our CO2 footprint by almost 50% by 2030. We have updated our sustainability strategy in May 2022. And of course, we want to provide net zero concrete to all our customers by 2050, also very much in line with the ambitious GCCA roadmap. So we focus on three main levers: products, process optimization, and CCUS. And it's clear that I think emission reduction must come first, right, before we capture the emissions. So improving the clinker to cement ratio is extremely important in this mix. And that is why the product side here is something we also focus on a lot. But so far we have used mainly the more conventional SCMs like slags or fly ashes. But as Karen mentioned, I mean, these are globally on decline. So we really need also to look at other materials in order to reduce the CO2 footprint in the future. And clay is widely available, and when exposed to a well-controlled thermal treatment, they can be also really turned into highly reactive SCMs. So it's really something which we believe could be a great solution. Also because these clay reserves are available in regions where we don't have access to other materials. And of course the advantage is that they are considerably reduced CO2 because they are only associated with the fuel and the electric energy necessary for their activation. So in addition to our sustainability targets of 50% reduced CO2 by 2030, we are also aiming to achieve 50% of our revenues by 2030 through low carbon and sustainable materials. And that includes either 30% reduced CO2 or 30% recycled material. And in that, of course, we also have the SCM solutions covered. So I'm going to show you two of our main projects on calcined clay. Of course, we are looking at different projects around the world. I think the most advanced and the biggest one in our group and one of the biggest future calcined clay plants in the world is the one we are developing right now in Ghana. We do it together in a joint venture with a local cement producer called CBI. And we believe that we can reduce emissions, the specific CO2 emissions on the plant by 16 to 18%, depending, of course, on the actual product types we are going to commercialize. And this project is currently under development, and it will go live by the end of 2024, depending on the final certification process, of course. So that will really help to decrease the CO2 emissions in the country. And it was just announced, I think, recently in the last 4 weeks that one of our competitor companies will also install a calcined clay plant in Ghana. So that is really one of the key solutions for that country in order to improve the cement manufacturing process. And here you can see the actual plan of how the plant will look like next year. As I said, construction is very much ongoing. We are using the engineering company FL Smith for the actual design, and we are only using local contractors for the construction, so the process also contributes to jobs and employment in the region. And another project I would like to introduce is the calcined clay plant in Boussac in France. I think we have announced in May this year that we're going to invest 65 million into that plant. That actually comes in addition to the 46 million we have announced earlier to decarbonize the energy side of things. So we will increase the alternative fuel rate in this plant from 30% to 80%. And the project is also financially supported by the Ecological Transition Agency in France with around 15 million, which comes from the French recovery program. And also here we are aiming to reduce the site's CO2 emissions by around about 20%. So we are really talking here about the specific emissions of the plant, which will translate to around 100,000 tons emissions per year. So that has a significant impact on our footprint in France. So overall, we firmly believe that the commoditization of the cement and concrete in the world is really coming to an end, and that we will see more and more low carbon and sustainable solutions, which will also be the main differentiator going forward, and which will really drive our business. So it's clear that this is the direction we need to take. We need to look at all the different solutions, but SCMs, in particular calcined clay, as Karen explained earlier, is really a key part of it.
Thank you, Winston. Thank you very much. And we see many projects. I find it's impressive compared to last year. It's still a work in progress. We would have loved to be able to announce that the same way we have a tracker for carbon capture project. Leadit is working with the GCCA for a tracker on cement, but I'm still not happy enough. So it's still work in progress, but soon we will announce a calcined clay project tracker, so that we will be able to follow live and online the building on all those new projects and announcement. And with this, I will pass the floor to Manoj Rustagi, CSO of JSW Cement. I don't think you have slides, Manoj, but we had enough slides. You will talk.
Thank you. So I'm from JSW India, part of the JSW group, and we are not as advanced as Heidelberg and Holcim in terms of the LC3 production and the capacity generation, but just wanted to share the work which we have done. So we essentially produce slag cement in India today and our clinker factor even today is around 40%, so which is very, very low. And we are in the southern part of India and the western and eastern part of India where the slag is available. So the problem specific issue for us was we wanted to go to northern part of India to set up a new cement plant, and there is no slag available. As Karan said, the slag availability over a period of time is anyway going to reduce. But in the northern part of India, there is absolutely no steel plant which is there, so there is no slag available. And that is when we started looking at the LC3 as a solution. So the good thing is we have done the test work for the clay and the suitability of the clay. This is done with Karen and her team in India with IIT Delhi, Indian Institute of Technology. And extensive work has been done to identify the suitable clay for calcination. So ranging from 45% kaulanite to 50-55%. That's the range which is available. And the test results are very positive. So now we have decided to go ahead with the project, and we will be awarding the contract for the construction and engineering sometime in 24. And this plant is going to be for 500,000 ton of the calcined clay. The total integrated plant is going to be around 5 million ton. So 500,000 ton is going to be for the calcination of the clay. The one of the thing which I'm as an individual, we are working on, it is still a work in progress. The temperature for the flash calciner, we are looking at flash calciner as an option, and the temperature requirement is much less than the kiln. And this is in the state Rajasthan, where the concentrated solar thermal is a very good option. So we are seriously looking at integrating the CST, with this LC3 plant, so that this is going to be zero fuel. There is absolutely no fossil fuel which is going to be used in this plant. So that's it from my side. That's the update. Thank you.
Thank you. Thank you so much, Manoj. And I think we have a little bit of time. So maybe our four speakers, the one who are present, you could join us here. And I don't know if there are questions. Just join us on the panel, Winston, Cedric, and Manoj, I think. Are there some questions from the audience? I want this to be a bit more participative. Hugo, you seems like you want to ask a question.
A quick question regarding, of course, the intensity of CO2 is one thing. There are percentage reductions between 10 and 50 odd percent, but the absolute amount emitted is increasing, no? For each plant, because we are adding capacity to the plant. Is that am I reading it right, or?
Well, that's a very complicated question because, we need capacity to satisfy demand. So, I talked a little bit about how we can reduce on the demand side. What we've got to look at is, I think in the long term, it's going to be very, let's take the example of China, because we don't have anyone from China here, so I can talk a little bit openly. But in China today, they have 1,500 plants. They see the demand reduction in China as being to 2 or 4 times what it is today, which means between half and 3/4 of those plants normally will shut. Well, in that scenario, even in that scenario, calcined clay can be an interesting option, because if you focus on the larger, most efficient clinker plants, and there you can install a small number of CCUS facilities, but then convert some of the other plants to calcining clay, and there you can have them as sort of grinding calcination plants. There you can still optimize your reduction strategy. But this is the problem. We're going to see many parts of the world where demand for cement is going down, and other regions where it's going up. And I think we're going to see big changes in terms of, how we move clinker around, that we focus on very large, efficient and carbon capturing plants, and then locally combine with calcined clay, which, as you saw in a couple of examples, can even be done with zero CO2 if you're using biofuels or solar energy or something like that.
Anyone willing to add? No? She just said what you wanted to say. Okay. Okay. No. I'm sure that. Do we have other questions? Thomas? Oh, you have other. Thomas, and then you.
I have another question. I mean, what is the future? I mean, we have a long discussion on the clinker factor down the road. I mean, what will be the substitutes, the SCMs, etc. What are the latest discussion in your groups, guys, on the potential of calcined clay? Because now we have seen project, it's growing, but how do you see the replacement on the substitution with over existing SCM like fly ash on slag across your groups?
Thank you. You know I don't. You know I don't have the answer. But what I do know, what I can tell you, is that it's not a silver bullet. In none of the countries it's a silver bullet. It's something that is incremental. Experience will be shared. We need to start with a full scale, and that's the project in Saint-Pierre-la-Cour, with a fully fledged production which has zero CO2 or close to zero CO2 in the production process, mature those process and then share the recipe and copy paste in other countries, but that will be progress. But it's an integral part of, similar to the numbers are varying a little bit, but similar to what Winston showed for Heidelberg Materials. It's part of the widely available tools that we have at our disposal.
Yeah, I mean, I just can add to that. I think we fully agree. It's part of the levers we can use, but it's not the silver bullet, and it definitely will not get us to net zero. So we need to work on all the different technologies, and also I think what is important, that what I mentioned before, is that we need to look at regions where we don't have access to other materials. So there, it's like in Africa, for example, where Ghana, where we have huge resources of calcined clay. Also in other regions, but there we really, that's, I would say, one of the main solutions to drive the decarbonization process. And then, of course, what also plays a huge role is the quality of the material, right? So if it's wet or dry, if it's wet, then this makes the whole process much more energy intensive and much more expensive. So it's really also about not just the quantity of clay, but also the quality.
No, so Thomas, most of the time we discuss on the transition in terms of the acceptance of the LC3 in India. So I don't think so. We've got a project, which has used LC3 cement. JK Cement is talking for the new airport near Delhi. This is with the Switzerland. I think there is a collaboration. So that's the first building which is going to be constructed, with some LC3. So the major, I think, in terms of the suitability of the clay, India has got very good deposits. So geologically, that is not an issue. CO2 reduction, I think it is simple. The fossil fuel substitution in the flash calciner is also the option with the alternative fuel and the solar thermal. It is just that how fast we are able to transition in terms of the usage and the demand. For the people to start using LC3. So that's the biggest question we have when we talk about it. Yeah.
If I may, Karen, before you go, if I may, because I heard you once say calcined clay is really a solution for the developing countries where they will go for, they will need more capacity and the availability. Can you elaborate a little bit more on clay's availabilities in Africa?
Yeah, it's a shame I didn't have the map, but the problem of Africa, you've got these very sparse deposits of limestone, and almost limestone and clay are complementary. Where you don't have limestone, you have clay. this is true in Europe, except they're much more mixed up on a much finer scale. So you have, limestone and clay on a distance of a few kilometers, whereas in Africa you're talking about thousands of kilometers difference. And this is why, Ghana, which Winston talked about, is a great example, because there's virtually no clinker production there. They have to import all the clinker. The cost of importing clinker now, particularly post-pandemic, is just ridiculous. And if you can replace half or more of the local material, and kind of touching on Thomas's question, where can clinker factor go? It's quite clear with working with people in these countries that ultimately we can go to clinker factors much below 50%. Exactly how much is an open question for research. That's why we're working in Rylem on cement performance standards to try and have robust methods, because clearly, 70% clinker and the rest in LC3 is not the same as doing it with fly ash. We did a comparison with the natural pozzolans in Chile, and we could meet the cement they have on the market with 65% clinker. We could meet that with 25% clinker. I'm not going to tell people start producing with 25% clinker today, because we have to do more research. But what I'm saying, the potential for 2050 is really right down there.
Thank you, Karen. That's exactly what I wanted you to say. I'm hearing you too much, but I think it was important to share this. Hugo, one more question.
One more question, just based on the actual industrial experience. One of the beauties of limestone or clinker is that you don't have to be very proficient operator to end up with no waste. Everything goes in the product, and the plant. Even if you're not that great, zero waste. Is that the experience you're seeing with calcined clays as well? Because I see that the calcination is kind of delicate in terms of process control, or at least that was my perception. But it's you can also end up with no waste, or you are seeing it already on the ground.
I think it's for you, Karen.
Well, if I can speak independently, the first trial production we did, it was in Cuba with a very unsophisticated old-fashioned kiln, and it worked. So, if they could do it there, I think they can do it anywhere. The process window is quite large, and we're even looking at for these very low clinker contents where we can go with 30, even 25% clinker, how we can activate it more. And one of the best activators we found so far is clinker kiln dust. So there could even be an option for getting rid of some of your clinker kiln dust eventually.
Thank you. We have a question there, and then Thomas.
So I understand that it's not necessarily the silver bullet, but and we need more. But if you look at sort of the short-term action, it seems like for very short-term impact, it is sort of a silver bullet. Is this also how you see it? And then I guess the question is, because Claude mentioned that last year there were not as many projects, and this year already a lot more. So my question would be, how can this scale even faster, and what would be needed, and what are bottlenecks to it?
Winston?
I think that's why we see more and more projects popping up, right, from us and also from our competitors. So it is definitely a technology which is there. Some more research has to be done, but I think we will see an increase of the use of calcined clay. I think but there are also some challenges to it. One thing which was mentioned are the costs, and the costs have increased. So it's also quite capital intensive, and the costs have increased quite a lot since Corona, since the pandemic. Depending on the quality of the clay, it's also very energy intensive. So that can drive the costs a lot as well, and depending on the energy we have available on that site, that will also impact the CO2 performance. And then of course we have also the issue with the water. So if it's a very moisture clay, then we will have to deal with the water excess coming from it. So there are still a lot of questions, I think, to be clarified, but it definitely is a solution available today.
I will just just add one thing. You also need, in my slides I insisted on the marketing, you also need to work with your clients. Because you have a new product, you need to have client acceptance that this product is suitable for whether it's mass precast projects or small bricklaying applications, but you need to educate your customer base and they have to accept it. So it's, you know, both of the two sides of the coin.
Thank you. One more question. Cedric may have to squeeze out, but yes.
Just to quickly react, I think it's all the pictures that we've seen today. Is that not so? Would that be convincing enough with all the different applications? Maybe, I don't know. And then maybe to your point on the energy costs that it may increase or the capital cost, if you compare it to a clinker plant, both are still lower, right? Because temperature is lower and it's a less complex system. So in that comparison, yeah, okay, good.
And that was actually my question. It was the customer acceptance. I mean, what is the first feedback from customers? I mean, I see on your picture, Cedric, that you even have not changed the color. I mean, in Mexico, I see the calcined clay goes reddish. I mean, what is the return? I mean, on how did you position high premium brand or on what is the return from the market?
I suggest we go for last round of answer on the color and the market acceptance, and then we close. Cedric.
Thomas, to be honest with you, I don't know what's the answer from Mexico. But you know, Waters, yeah, of course there were beautiful slides, but it's not that many projects. I mean, it's it's experimental. We are producing now. We started on a relatively large scale of 100,000 tons in France. It's not available everywhere. It's not in all projects. It's a start. So yes, it's convincing, and yes, we've got different range of applications, and yes, there are interest for some application, not the other in other countries. So yes, it's convincing, but it's incremental. It's not the silver bullet, and we're not going to deploy at scale everywhere at the same time. It's market by market.
But if I could answer on color, I think the answer is, what we see in the field. You saw in that example of Mexico, well, the render, it looks like adobe. So, I mean, it looks like you're using, the local traditional materials. And, we've seen this everywhere. Everybody says we don't want red color. When we made the demonstration house first in India and we made the roof tiles, they couldn't actually keep enough roof tiles for the house because people would insisting, I'll pay twice as much for a red roof tile as I would for a grey, which is they're selling beforehand. I visited Cement in Switzerland a couple of weeks ago. Again, they had people, made a first demonstration of these big blocks people use around the sites. And again, they couldn't keep the pinky colored ones on site because people preferred them. So I think, quite honestly, we're seeing it's a little bit of a myth that people don't want red cement, and it's a lot more pop people reckon. And I think Holcim have got exactly the right strategy. Don't bother changing the color, just tell people this is a good point.
Excellent. So I will close the panel. I'm sure we are all at COP. We can continue discussing the topic. I know that some of our panelists have to rush to other events, but we can keep the conversation going on. Stay tuned, because we are going to release this mapping of projects. I think that's important as well. And because I see a few new faces, don't forget to take your copy of our progress report before you leave, because there are many more topics covered there. And see you for our next event, which is at 4 o'clock, I think. Is that right, Paul? Is it 4 o'clock, the next event here? 4 o'clock on roadmaps.